Cool. Hello. All right, excuse me while I repeat myself for just a moment. We've just opened up Unreal Engine. We created a template from the first-person shooting template. When the project boots up, you're given this entire view, the view of the entire Unreal Engine. There are a ton of different windows. We're going to go over them one at a time. The one in the center is the viewport for your level. A level is very similar to a scene in Unity, or a room in GameMaker Studio. I find the easiest way to move around is you hold right-click and you move your camera around. You can also move around with the arrow keys or by zooming in and out. Great. To see what they've given us, we hit the play button, and that shows us what we already have working. What happens when we hit play? A first-person character is loaded into the scene. We can move around with our mouse, click to shoot a physicsy ball, and press the spacebar to jump. That was the fast version of what we just went over. By pressing escape, we end the preview, and we're back in the editor. So let's go over these windows one at a time. As I said, this one here is the viewport. You're able to look around. You're able to select any given object. And very similarly to Unity, you'll find that you're given this sort of 3-axis set of arrows, which enable you to move an object around. If you move it up, it'll move up. If you move it right and left, it'll move right and left, forward, back, etc. One very fun distinction between Unreal Engine and Unity is that in Unity, the 3 axes are X goes left and right, Z goes forward and backward, and Y goes up and down. In Unreal Engine, X goes left and right, Y goes forward and backwards, and Z goes up and down. Something to keep in mind if you use both engines. It gets quite confusing. Cool. So that is the viewport. It enables you to place objects. We'll come back to it when we have some objects to place. On the left here, we have what I'll describe as, if you've ever worked in Visual Studio to create an actual WinForms application, or if you've ever worked in MS Paint, you know that there's your dock of tools on the left side, the toolbar. That's what this is. This is a toolbox, if you will, of different things you can place into your world that come pre-baked. So you'll notice there's empty character, empty actor, empty pawn, point light. Some of these are pretty self-explanatory. For example, there's a cube. Just like in Unity, we right-clicked, set create cube. Here we dragged a cube in from the toolbox. If we move it up a bit, it's going to be a cube. Hitting play and going to find our new cube, you'll find that unlike the cubes that UE4 gave us, this one doesn't do anything. However, it does have collision. That's because all things in UE4 have collision unless you tell them not to, especially these pre-built-in objects. These are some, what I'll call, they're models, but UE4 calls them static meshes. They don't move, it's a mesh. Placing one in, it by default has a collision of some kind, but that's it. There's no physics, there's no code, it's not listening for anything, it's not doing anything every frame. It's just sort of hanging around existing. But that means we can use these to create levels. So really quick, we're going to create a staircase so that we can get up onto one of these higher boxes that we can't reach yet. So taking this cube we just created, I'm going to zoom out a bit, and I'm going to physically drag it towards here. So you can also probably do this a bit easier if you drag it right where you want it. So if I just click from the cube and physically drag it into the world, you'll see it starts putting it wherever my mouse is. So I could even do this right along where I'm looking for, and we'll just do that a few times. So let's do that. Say I want to pull these out a bit. You can control-click, just like in Windows Explorer, just like in a bunch of different programs, to select multiple things at the same time. Then, if you've clicked multiple things at once and you do a drag, it'll affect all of them. Importantly, it will not put them in the same place. It'll maintain their relative differences. That's why you can see me moving it up and down, but they still stay a staircase. Very handy. So far, any immediate questions, or does this all sort of make sense? All we've done is brought a pre-built mesh into the world and moved it around. I'll add one more because it looks like we might need it. And let's hit play and see if we're able to climb our staircase. So looking around, we'll find our staircase, and we'll have to jump, 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 jump. And now we're on top. Woohoo. So far, so good. Let's see if we can jump from here to one of our physics cubes. We are able to. Excellent. So I find a bunch of things about this first-person template that they give us a bit underwhelming. I find the physics feel very stiff, especially in midair. You have almost no control over where you're jumping towards. It somehow feels simultaneously floaty and heavy. I don't know how they manage it, but it feels both. So we're going to tweak. I'm going to show you guys where to tweak some of these things to make it feel however you'd like. But a sort of warning ahead of time. We're using a pre-built Unreal Engine asset here. They're very powerful. They can let you do a lot of things, but they're very different from when you build some functionality from scratch. And I've found that when you try to mix the two, occasionally you run into some issues. So this player movement script is handled by an Unreal Engine 4 created player controller. It gives us a ton of variables to control almost everything about how they feel, what steep an angle they can walk up if it's a ramp, how high of a stair they can sort of lip over, all these things. As soon as you find something they don't have a number for and you want to create, it may or may not become a bit tricky to work with. So just be warned that you may run into some complications ahead of time. But that said, where would we even go if we wanted to edit anything about this? The answer is in the content browser at the bottom. Just like in Unity, this gives us a sort of folder view of everything in our project. I'm also going to click right here. There's this little button in the top left that says Show or Hide the Sources panel. I'm going to click that. That gives me a handy drop-down view over on the left. I like that view a lot more, personally. So we're going to go into the first-person BP folder. I'm going to talk a bit about Blueprint now because it's important. Unreal Engine 4 has a visual scripting language called Blueprint. You can create game logic. You can create an entire game using nothing but Blueprint scripting. It's very powerful. Separately, Unreal Engine 4 objects are also powered by C++. I've found that the C++ editing is very not beginner-friendly. I found that it's much easier, at least as of now, to sort of create your functionality using this visual scripting than it is to go through and create C++ objects because they don't play nice together. When you create a Blueprint object, you're given a visual viewport to create elements of your object. In C++, you kind of have to dynamically create all of it using code. I haven't learned the best way to do it myself, so this will be a Blueprint-focused lesson, just so you know. Blueprint is also a word that's thrown around in many different contexts in Unreal Engine 4, and it gets very confusing very quickly. For your reference, Blueprint is the scripting language itself. I'm going to click some buttons. Oh. Close enough. Woo. OK, so Blueprint is the scripting language itself. A Blueprint actor we can think of as an object. It's an actor. You place it into your scene, your level. You place it into your level. It, just like a component in Unity, has a begin playing event, an update event. It can run into other things and have collision and perform all these things. So we're going to look into that. We'll be creating and modifying Blueprint actors. So in that same vein, our player is a Blueprint actor. So under first-person BP, which is what Unreal sort of gives us, we're going to go into the Blueprints folder. And we'll see a few things here. We'll see the first-person character, which, spoiler alert, is where we're going next. But before we go there, we also see the first-person game mode. And game mode is a very interesting Unreal Engine thing. The game mode tells the game what is the player-controlled Blueprint actor that we should spawn upon creation. It includes some information about networking and other nonsense things, how many players are allowed. A lot of this is built with more advanced games in mind. We're going to be not touching game modes for this lesson. Just know that the game mode is telling the game, hey, this first-person character is the player character. And that is, we learn that information from the game mode. Next up, there is the first-person HUD. All this is doing is drawing that little plus at the center of the screen, the crosshair. We could delete it, and it would go away. We'll leave it. We're not going to touch that either today. And finally, the first-person projectile, which is that little ball that flies around when we click the button. One of those gets spawned every time we shoot. We'll be messing with this in some fun ways, but we'll get there in a little bit. So first, let's open up our first-person character by double-clicking. Unreal Engine opens these as separate windows, but you can move these tabs just like you can web browser tabs, like in Chrome or whatever. You can dock it to the top, and now you've got both of these in one window. I was aware it wasn't going to record if I didn't do that, yes. Don't worry. So welcome to the event graph. To put it simply, you can think of this as a large code file. This is where the logic controlling your object goes. We can move around here just like we can in the world by holding right-click and dragging around. We can zoom in and we can zoom out. Those are your basic controls for navigating the event graph. How many of you are engineers and have used that one program that has logic that looks similar to this? You know it. I don't even remember the name of the program. Is it? I don't remember. Anyway, this is now the only. It might be LabVIEW. Anyway, anyone who's ever used LabVIEW might be familiar. This might look somewhat familiar to them. That said, so all you need to know is that fundamentally you're following the white line. If a node does not have a white line going into it or an empty socket going into it, you can assume that it is, excuse me, the start of an execution path. Yes? I right-click and drag. Is the easiest. Did that answer the question? Cool. So zooming out, you can see they've given us some comments here. For some reason, some of the comment bubbles are hidden behind code. I don't know why that's happening. We see if head-mounted display and motion controllers are used. That's some stuff for VR. We're definitely not touching that today. Hide VR orientation, blah, blah, blah. Movement input, stick input, mouse input, jumping. So that's all good. Well and good. It's important for us to know where these things are happening. Let's look through one of these at a time. I lied. We're not even going to look at any of those yet, because what we care about right now is understanding and changing how the character feels to move. And to do that, we have to look at our components window in the top left corner. So that's well and good that they tell us all the components, but how do we see them? We click over to the viewport tab. So we've opened a first-person character. We were at the event graph, which shows us logic. We've clicked over to the viewport. And now we see the same thing we saw in the world. It shows us sort of a third-person perspective of what this object really looks like. You'll notice off the bat, you may be wondering, why the hell are there two guns? And the answer to that is one of these guns, I believe, is used. Oh, it's for VR. Go figure. One of these will be hidden for no VR or VR, depending. You can see it's named VR gun. We're going to ignore it entirely. Pretend there's only one gun. It'll be easier for all of us. So in this viewport, we have a few things. We see this cylindrical object, or cylindrical wireframe. We see this camera that looks very much like a camera. And we see this, it's even moving in editor. You can see it bobbing slightly up and down. And that's the game previewing our idle animation. Oh boy, second time. We tried. Okay, so we're not going to touch any of this right now. We're going to go down to the very bottom of the components window. And you'll see at the very bottom that it's inherited character movement. This, because we're using sort of built-in Epic Games things, this is where all of the logic and all of the variables we can tweak are located. So even reading the tooltip. Character movement component handles movement logic for the associated character owner. It supports various movement modes, including walking, falling, swimming, flying, and custom. You see that they built this to be quite expandable, but I found that depending on the needs of your game, it's either best to go with this or really bake it, yourself from scratch. For the purposes of this demo, though, and just getting something off the ground, we're going to stick with them. So clicking into this, the details pane on the right is now populated with a ton of information and variables to tweak about this character movement. Scrolling down, we see general settings, gravity scale, which is a shorthand of saying how fast do they fall, max acceleration, braking friction factor, crouched, half height. We don't even have crouching yet. Mass, etc. We right now just have a walking state, so we're going to look at the walking variables. There's a max step height, which is how high they can step over in units. Walkable floor angle, which is very self-explanatory. Walk speed crouched, analog walk speed, blah, blah, blah. So what do we care about? We also care about jumping and falling. So I lied. We have two movement states, airborne and grounded. So because most of my issues pertain to how the character feels in the air, that's where we're going to focus first. We have jumping and falling. The default jump Z velocity is 420. I'm going to change it to around 600 and see how that feels, but we're not done yet. Looking else, we also see air control, which is how much of your ground movement the game lets you get up to in the air. It's at a pitiful 5%, or 0.05. I'm going to change it to 1. I want to have as much control in the ground as I do in the air. There's also a boost multiplier and some other stuff. We're going to leave it at those two things. So all I did was tweak the jump velocity and the air control, setting them to 601. Feel free to try other values. I would advise not making the jump power some stupidly arbitrarily high number. The game will basically, you'll fly so far out of bounds, the game will delete your character and you'll be stuck. But it is fun if you want to try it. So we've done that. All we did there, by the way, is we hit the compile button. When you make a change and it's uncompiled, you'll see a little gear here. You click it, it becomes a check mark. Now it's compiled. And then we can hit the play button. So clicking in now, you can see we jump higher. And more importantly, we have much more air control when we are in the air because we tweaked those values. We could go farther by changing the gravity scale to make us fall faster, and then we can jump even higher in that to really get a different game feel And really, depending on the needs of a game, you'll want to just play with those until you're happy with them. Let's say for now I'm happy with 600 because I'm able to make certain jumps. I'm now able to jump to these cubes and jump between them pretty effectively. So far, so good. And are there any questions so far? I've been moving a little quickly. Awesome. Cool. Now that we've done some basics, let's have some fun. So instead of going back into a first-person character, let's look at the bullet he's shooting. Oh, sorry. Right here at the bottom in the first-person BP folder, we've got the first-person projectile blueprint actor. We're going to double-click it to open it. And it's going to open up in the tab just like everything else. So you'll notice there's only a little bit of code here, which is in the event hit. All you need to know is that this is saying when this sphere hits something, then follow the white line and see what happens next. In this case, we branch, which can be thought of as the if statement of blueprint scripting, because you feed it a Boolean and it either follows the true line or the false line. And if the other component is simulating physics, then, and that's true, we add an impulse on that object. I just said a bunch of things very quickly, and if you're unfamiliar with visual scripting, that might have been confusing. Does everyone sort of understand what's going on here? This node starts execution on the white line. It also has what can be thought of as parameters in any other programming language as these colored lines on the bottom. Unfortunately, I can't zoom in anymore, so I hope that's big enough for everybody. Other component, if we highlight over it, it can try to tell us a little bit about it. It'll tell us it's an object reference, which isn't very descriptive, but all you need to know is that's whatever we hit, the other thing we hit, not ourselves. So by dragging that out and asking it, there's a built-in method here called isSimulatingPhysics, which just returns a true or false. Booleans are considered red. Every object type has its own color in Unreal Engine. So we follow this Boolean line and feed it to a branch node, which will either follow true or false, depending. Sort of like an if-else statement wrapped into one. And if that is true, that we are simulating physics, then we add an impulse on that same exact object according to some number. Does that sort of make sense? We also then destroy the ball itself. If all that makes so much sense, then we'll keep going. I don't want to loiter too long on it. But let's jump over to the viewport of our object. We'll find it's not especially interesting. It's a sphere with a material on it. You'll notice separately from the sphere there is a collision component, and that means that the model and the collision are separate. It's possible to make them be the same, so that we use the collision of the model, but for whatever reason they decided to keep it separate. But that is fun for us, because that means the model that we're using doesn't actually matter. It means that no matter what we change this model to be, the bullets will function exactly the same, because it's purely a visual thing. So that said, by clicking on the sphere, we see that it is a static mesh. Static mesh is Unreal Engine's word for model, basically. It brings in a 3D model from 3ds Max or Maya or whatever you decided to make it from, or you download it from the internet, and it puts it there. You can then apply materials to it. And a material is a texture with fancy logic on top of it, which is a broken way of describing that. My apologies to Richard, wherever he is. But the cool thing is we can change this with a drop-down. So by clicking the first-person projectile mesh, which is a fancy way of saying sphere, we can click this down, and every static mesh in the project becomes available to us. And this is where it's cool that we included the starter content, because they give us some cool meshes to look at for free. So scrolling down, you can pick anything. We can pick a cylinder, and it will change to a very tiny cylinder. We can click a quadrilateral pyramid, and it will change accordingly. We're going to find my personal favorite, the chair. This is a chair that they give us for free. And you'll notice it's very pitifully tiny. And that's because a transform, just like Jake explained in Unity, is a collection of an object's location, rotation, and world scaling. And currently, the scale is set to 0.1. We're going to change it to 2. 2, 2. It's real big. It doesn't matter. We're going to see what happens when we throw really big chairs around, because, again, we're not using the chair's collision. The chair might as well not be there for all practical purposes, because we're using a small spherical collision. So the model doesn't matter. And let's see what happens in motion. Feel free, by the way, to pick any model you think is entertaining. We're going to start playing, and we're going to launch large chairs in the scene, as many of them as we want. They're going to bounce all over the place, send our cubes flying, and then disappear after a few seconds, because that's what they're programmed to do. So far, so good. Any questions about what we just did? All right. Say again? Oh, the lighting needs, so that's a fun question. So the lighting needs to be rebuilt anytime a new mesh is brought into the scene in Unreal Engine. Because meshes, you can set them to use dynamic lighting, but by default they use static lighting, which means you have to bake the lighting into the scene. These 4 cubes we added as a staircase are considered new meshes. And so the game does its best to approximate lighting. I certainly can't tell the difference, but the engine will yell at you about the lighting needing to be rebuilt. You notice in very faint red text right below it, it says, disable all screen messages to suppress this message. You can do so, but I personally leave it on and only build lighting once I'm done, adding a bunch of meshes to the scene. So far, what we've done is we've gone in, we've found ways to sort of look at the viewport and change some values, but we haven't actually made any new code do anything. So I think we should do that next, and it's going to be a lot easier to do that if we do it from scratch. So I'm going to stop playing here. Everyone's still with me? In the first-person BP folder, we're going to right-click. We're going to create a new, we need to create a new blueprint actor. So I believe it's blueprint. I guess it's just a class? Huh, guess so. So we're going to create a new blueprint class. Once we right-click, it'd say blueprint class. It's then going to give us a bunch of options. Because this is going to be a generic object in the scene, it's not going to be playable. We're not going to add some of those extra hooks. We're going to make it simply an actor. You'll notice there's a very large brick of text about what it means to be a blueprint actor in UE4. For our intents and purposes, think of it as an object in GameMaker. It is a thing that exists and has logic in it that runs at the beginning when it first comes into existence and every frame after. So we're going to click Actor. We're going to name it Rising Platform. So far, so good. We've created a new blueprint class, called it an actor. Yes. I right-clicked in the content browser, went to blueprint class. On the next window, I clicked actor, and then it was existent. Then I named it Rising Platform. So far, so good. I'm going to speed this along because I know we only have so much time. We're already over schedule, and people have other stuff to do today. So with me so far, we're going to now double-click Rising Platform to open it. And it will give us the viewport first this time. I'm not sure why it does that, to be honest. But now that we're here on our Rising Platform, you'll notice this random sphere. This is called the default scene root, and the game does this the engine does this just so that you're not looking at literally nothing. This sphere would never show up in game if you placed it there. It would just indicate that there is something there. It is only shown in the editor, not in actual gameplay. So that means we need to add some stuff to this object because it doesn't do anything. So just like last time, we're going to add a cube. So I say last time as in Unity. To add components to our actor, unlike in the level where we were able to drag them out, here we need to add them one by one. So to do this, we're going to add a component. We're going to type in static mesh. You notice we get a bunch of options. I'm not going to go into the particular different options. We're picking the bottom one that just says static mesh. So far, you're with me? We clicked add component, typed static mesh, and we're picking the one that just says static mesh at the bottom. We click that. I'm going to leave its name just as static mesh for demonstration purposes. So now, just like with that sphere that we changed into a chair, this lets us pick any mesh that we have in our project from this dropdown now. To keep things expedient, I'm going to type in cube, and we're going to pick the top one, which is a 1 meter cube. We now have something in our object. It is a cube. I want this to be a rising platform, which means I want it to be not so tall, and I want it to be wider. I'm going to do that by changing the scale. We can type the scale, but we can also click and drag the scale. Up here along the top, you'll notice we're on the Move tool. And we've been on the Move tool the whole time. If we change this, we're at the Rotation tool. And if we go again, we're at the Scale tool. The shortcuts for this are W, E, and R, by the way. If you click W, you're at Moving, E at Rotation, and R at Scale. But you can also just go up and click this. So now watch. I'm going to scale this to be smaller this way, and then wider in these two ways. I'm going to make them 2 by 2. So far, so good? Awesome. Everyone sort of on board with how we brought a cube in and we changed its scale? Go once. Any questions? Good. All right. So now that we're going to do one more thing. Because how these platforms are going to work is that when the player steps on them, they're going to start moving upwards. So to do that, we need what's called a trigger region, so that we can actually listen for when something walks into us. Because this is a solid collision, nothing can walk into it, they'll only walk onto it. So we're going to add one more component. We hit Add Component, and we type box. And there's something called a box collision component. So I hit add component and hit box component, box collision, and we created it. I'll leave it as, I'm going to name it collision. So you'll notice it's sort of stuck inside of our platform. I'm going to click the movement tool and drag it up a bit, and now you'll see sort of the box itself. You can pan around here to get different views of what it looks like. We're going to leave it just as that. We're not going to change any of its sizings or whatever. I think it's fine as is, because it actually, you'll notice its scale is 1 by 1 by 1, but it actually is stretched. That's because it's a child of our static mesh, and so it will scale along with its parent. Does that make sense? Cool. Now that we've created our collision, I think we need to specify that it's an overlap. Yeah. So right here, under collision, we've clicked on our collision object. And on the details pane, we scroll down to the collision section. The collision preset is the important thing here. We have it on overlap all dynamic. That means we can overlap any moving object in the scene. That's important. If we had it set to block, you again would sort of walk into it as if it was an invisible wall. So thankfully, the default settings are what we're looking for here. Now, I'm going to hit compile because I hate seeing that little question mark. We jump over to the event graph. And you notice they give us 3 things right off the bat. They give us a begin play, which this runs exactly once the first time this object gets spawned. There's a begin overlap, which we'll be using very shortly, which is any time something else overlaps with us or we overlap with something else. And finally, there's tick, which you can think of as the Unity update script, which happens every frame. So we care about begin overlap first. But before that, we actually have to know what we're going to do once they overlap with us. And that's that we're going to start moving upwards. So first thing we need to know is we need to know if our platform is on or off. We need a Boolean for that. So under here, on the left, we have my blueprint, which shows us all sorts of different information. Most importantly for us, we have the variables section. And just like creating variables in any programming language, this is where we're going to create them. So we're going to make a new variable by hitting plus. It's going to pick a Boolean by default, which is very convenient right now. And we're going to name it on. Oops, I hit an extra character. You change its name up here too. We create a new blueprint on, and it's once we hit compile, we actually see that once we click a variable, the details pane on the right changes. And you'll notice at the bottom here, we have a default value. Booleans are shown as check marks in Unreal Engine, and unchecked is false, checked is true. So far, so good? Any questions? Excellent. So on is currently set to false. So far, so good. Next, we want to know how fast the object is going to move upward. So we're going to make another variable. It's actually going to be a vector 3, just like we saw in Unity. A vector 3 has 3 float values in it that represent x, y, and z directions. So we're going to call it movement. And now we have to change its type because it's still a Boolean. The second option in the details pane is variable type. We're going to drop down. We're going to see a bunch of different things. We see Boolean, byte, integer, int64, float, name, string, text, vector. We're going to pick a vector. Vector 3s are the default. Once we've clicked the type, we hit compile again, and now we get our default value. And again, remembering that z is up and down in Unreal, not y, we're going to set our z value to be 25. Positive is up, negative is down. Pretty intuitive. So now that we've set our default value, let's first just assume it's always working. So for something to move over time, it needs to move every tick. So this logic has to go under event tick. So that's all well and good, but how do we do that? So we're here in our event tick, and we can drag stuff out by dragging the white line. You get a ton of different things. That's not especially helpful yet, because what would we type here? Move myself upward? We need to move a part of ourselves upward. I find it, instead of dragging out, I find it easier to sort of right-click and think about what you want to do. So right now, we want to move an actor. So let's try typing move actor. We get a lot of different options, none of which are actually what we're looking for. OK, maybe it's set position. Yep. And upon typing it, we find set actor location. And that's what we're actually looking for. So by double-clicking set actor location, we are given a new node in Blueprint. So you'll want to right-click and type set actor location and click what comes up. Once you do that, this will show up. You'll notice a target, which is defaulted to self. That's good because that means it'll be changing the location of this platform. There's a new location, which we'll have to figure out how to set. And then there's the difference between sweeping and teleporting. We'll look at that a bit later. I believe we'll be wanting sweeping. So in order to do this, we need to figure out a new location to put it at. Mathematically, that is just our current location plus our change in location. That's well and good, but how do we do that? So the first thing we're going to need is to get our location. So we just right-click and get actor location. And sure enough, just like set actor location is a node, so is get actor location. We hit that, and you'll notice there's no execution pin. That's important. You can just pull these values, and it will just give you them without needing to sort of run a line of code. It's the difference between typing a variable name and typing a function call with an open close parenthesis. The difference between returning a value and actually doing something. Does that make sense? So we have our current location. Now we need to add it to something else. So we physically pull out from this vector node that they give us, and we release the mouse. And all we do is type plus. And you'll notice the first thing it gives us is vector plus vector, which is exactly what we want. So then we tell it OK. And now all you can see is that we need one more node. So we could just add the movement node and then put it there, and we'd be done, you'd think. However, games these days run at variable frame rates, especially Unreal Engine. Whereas in GameMaker Studio, you can be confident that the step function runs exactly once per frame, and that's 60 frames per second. In Unreal Engine, your game could be running at 20 frames per second or 144 frames per second or more. Yes? From this one? Yeah. I just typed a plus. And the first thing I got was vector plus vector, and I clicked on that. And you'll notice it automatically snaps our result into the first thing of the node, which is all well and good. So how do we get around these variable frame rates? Because if we had a 20 frame per second thing, our platform would rise incredibly slowly, and 144, it would rocket off into the sky super fast. We do this by scaling by delta time. You'll notice event tick actually gives us a parameter called delta seconds. This is the amount of time in seconds that has passed since the last frame. This is a variable number. All you need to know is that by scaling a constant by this number, you can be assured that it'll move at the same rate regardless of your frame rate. This is a very handy trick in Unity and Unreal. So what we'll be doing then, we need to multiply this. So I'm going to drag delta seconds out and type an asterisk for multiply. We're going to get a bunch of different things, but we care about vector times float. So we click that. And now, so that's first. You click from delta seconds, drag out, and then type the asterisk, which is multiply, and then you multiply a float times a vector. Now we're going to drag our movement variable out into the event graph. All we do for that is we hold our mouse over it and click and drag it out, and we release. You'll notice we're allowed to either get it or set it. In this case, we're getting it, and it'll just come out this cute little node. And all we do here is we point, click, drag, and release. And now this node is equal to our movement value times delta time. Make sense? Now we click the resulting vector we get here into our addition with our actor location. And now we've said get our actor location, add the movement, but that movement scaled by delta time. And that, finally, is going to be our new location for our actor. Does that make sense? I know we just clicked and dragged a bunch of squiggly lines. Excellent. You'll also might notice very quickly, this gets real messy real fast. We already have lines crossing each other and squiggling over each other, and it's not the prettiest. There are ways to make it prettier. We could choose to move this down here, but now this execution node has to go through everything. We could move this down here and this down here, but then this goes over that. There's a ton of different ways to deal with this. I'm only going to teach you one thing right now. If you highlight over any given line and double click, it creates what's called a reroute node. These affect actually nothing except for the visuals of the blueprint design. And now I can drag this reroute node and I can make it go around or behind or whatever. You can use this to make much prettier blueprint code if that's something you're worried about. We're not going to get into that any further for this though. So all we do now is we connect our event tick execution line to our set actor location. Are you all with me still? OK. To read what we just did out loud, every tick, we set our actor location. We're setting the location of self, and their new location is the sum of their current location plus movement scaled by delta time. Does that make sense? We were able to follow the execution line for the high level, and then we could follow each variable backwards to sort of read what we were doing. It's a weird frame of mind to get into, and it's quite different from typical programming, but I found it makes sense once you get used to it. Any immediate questions with how we set this up? Awesome. So now we're going to hit compile and save. And we're going to go back over to our actual level. Now that we're back, we're going to click and drag our rising platform into the scene. I'm going to make sure I do it right in front of our character because you'll find it starts rising upwards immediately. So I click this rising platform out, and it's this little gray platform right here. Now I hit play, and you notice it starts rising very slowly. And that's because 25 sounded like a big number and all because 25 units is pretty far, but now it's getting scaled by delta time. And when you think about 60 frames per second, delta time is typically 1/60, a very small number. So now we would go and we can change how fast or slow we start rising. So really quick, I close that out. And all we got to do there is we got to click on our movement variable. I clicked back over to rising platform and hit movement. What if instead of 25, we say 125? And then we just hit compile, save. And we click back over to play and hit start. Now it's moving much faster. So that's nice. It'll rise up forever because we didn't tell it to stop. It'll just do this until it eventually is out of the player's sight. We're not going to get too much farther. The last thing I want to show you is how we can now make it only start rising once the player physically interacts with it, physically steps onto the platform. So to do that, we're going to need to use a new node. Tick happens every frame, but the actor begin overlap only happens when something overlaps with us. In our case, it's going to happen when they overlap with that box we created called box collision. So we have our event graph. The first thing we need to do is we need to check if the thing that overlapped with the platform is the player. We do that by dragging out from the other actor tab, parameter, and we type cast. So casting you might be familiar with in other programming languages. You can cast a float to an integer. You can cast, I don't know, an object to a sub, like a what's the word? Polymorphism. You can cast something to its parent class, whatever. In this case, we can try to cast this is a generic actor, so we can try to cast it to any specific actor. It's going to give us a node for if that cast succeeded and if that cast failed. And this is a very handy way of checking if something that collided with you is the object you care about. So we're going to type BP character. Sorry, it's first person character. So I typed cast first person character, and the first option is cast to first person character. We double click that, we get a node, which says cast to first person character. You'll see two nodes at the top, or the two nodes here. There's normal and cast failed. If cast failed, that means the thing that overlapped with us just isn't a first person character. It might be a bullet, or it might be some other object we end up creating, or another first person platform, another rising platform somehow. For those, we don't care. We're just not going to do anything. So we'll leave this node untouched. It's OK that nothing further happens. But if what overlapped with us is the player, we want to start actually rising. So we're going to change the value of the on variable to true. So we click out from on and drag it out here. And instead of getting, we're going to set this time. And we're going to set this variable to true. We do that by choosing the value right here. We set it to true, and we drag out from this top here to the set variable. And that's it. Now we compile. We could go in. I'm spoiler alert, we didn't actually get it working yet because we don't use this on variable anywhere. So going back down to tick, we need to create a branch. So first, we drag out from on again. And this time, we get its value. We drag out from on and type the word branch. This now creates a branch node that either has true or false. And in our case, we only care if it's true. So first, we drag back out from our tick node to change where it goes to be into the branch instead of into the change immediately. And only if it's true do we set our actor location. Now that we've done these things, it shouldn't move, and then the player will step on it, and then it'll start moving. And then we can answer any questions, and I'll wrap this up because I know it's been going long. We hit play now. So we see our platform. I can shoot at it, and nothing will happen. But I can step onto it, and it starts rising, just as we thought. If all of you have that working, you have now created an object from scratch, checked for collisions, and made it do something every frame. Are there any questions? Do you want me to show you how to do anything specific? We've shown how to place objects into the scene, how to give them code, etc. Yes?
Could you go back to
the event graph?
Yeah.
Yeah, sure thing. So here is our event graph in its entirety. I'll zoom in and drag this all down a little bit. There we go. On begin overlap, we set a value. Yes? So event actor begin overlap, and then we cast it to a first-person character. So you type cast first-person character. And this is just a simple way of checking if one actor that's alighterless is a thing. Yes, Jared.
Is there like an on-end overlap?
There is. We can make it turn off as we step off. Yes.
Is it theoretically as simple as having the same like 3 blocks to turn the variable off?
Yep. So I can even do it right now. Watch. Right-click, event, actor, end overlap. Exactly like you said. We click it. It's there. It looks exactly the same, except it says the word end. Speeding this along, we're going to copy and paste the cast. Drag this in and drag the actor in. And if it succeeds, we set on to false. Compile, save, done. That took 5 seconds. Now, I'll prove to you that it works real quick. The platform starts moving. We hop off. It stops moving. I can probably jump to this cube and then jump to the platform, and it starts rising again. Yeah, first-person platformers. All right. Are there any other things we'd like to see? We made the gun shoot chairs. We showed how to place basic level geometry. There's a lot more that we can look into. There's an Unreal Engine lesson I taught last year where I went a bit farther into placing different block types into the level. If you'd like me to show you that, I can. I don't know how much time I have. E-board, how much time do I have?
You have until the epic land starts at 9 p.m.
Wow, okay. Ask me anything. What do we want to do? Make it as meme-tastic as we want.
Can we work on slides?
Yeah, stop the recording first.
Sure. I'll just close off if there are any other questions that would make sense for the recording. Yes? Sure, yep, sorry about that. Here's our total event graph. Nick? So currently, no. I believe the collision they have, what it probably does is it sees that the player technically has physics simulated on, and they hit you and they instantly despawn. We can change it so that you could. We could give them a second. We could make them not impart physics and instead just be a big platform. It might be very glitchy. We could try, though. Oh, you know what's fun? Once we stop recording, we can actually make the gun spawn rising platforms. Because why not? It's just spawning an actor. Anyway, any other questions that make sense on the recording? All right, then thank you very much, and I hope Unreal Engine is like at least 2% less daunting than it was when you first got here. Cool.